In this class, we are going to start a new lesson, chapter 14, Oscillations. So, this lecture is like an introduction for this lesson. What is oscillations? Oscillation is a repeated motion. The oscillation is a repeated motion taking place in a particular path. We call it the oscillation. But when you study oscillation, there are different type of oscillations are taking place. So, we study about two. In fact, finally, we end with one particular quantity. The first we will see one type of oscillation known as periodic motion. What is periodic motion? Is a type of oscillation. So it's a repeated motion. Okay, but when it makes repeated motion, certain conditions it has to fulfill. What are they? The repeated motion should take place about a fixed point. Okay, first condition. Second condition, repeated motion should be on a fixed path. And third condition, the motion should take definite time completed. Okay, if these three conditions fulfilled, then the motion can be called as a periodic motion. I'll give some example. Here the first diagram shows how the planet moving around the sun. You know planets are moving around the sun in the elliptical path. Where the fixed point? Sun is a fixed point. Path we know elliptical path. You know every planet take definite time to complete the motion. Okay, so that's why it's a periodic motion. Okay, in another example. So you take an elastic spring suspend from a fixed support at the bottom part of our body and slightly pull it and leave. The body moves ups and down. You have done the experiment to calculate force constant of the spring or spring constant of the spring. So how the body moves? It's moving about this point where originally it was there. That's a fixed point. About this body moves ups and down. Okay, it's moving about a fixed point. If we're moving on a definite path, a straight path, and you know it takes definite time to complete the motion. Okay, so that's another example for a periodic motion. The third example I have taken simple pendulum because that also you have done on experiment, so something familiar. Simple pendulum very easy to make. How you make in the lab? We take a spherical body, tie with a thread, suspend from a fixed support, then it hangs. Then you give a little push, body moves to and fro, and that is what you call a simple pendulum. Okay, and is it moving a fixed point? Originally, where was it? The bob? That's a fixed point, and moves on a fixed path. And quite opposite, it takes definite time to complete the motion. In fact, time interval to complete the motion is fixed. It is not changing. So based on this idea only, so they made a pendulum clock. Before pendulum clock, you know, time interval measured by different technique, but those techniques are approximate methods. They are not exact. For example, using sundial, they used to measure time. What are the problem? One is sundial can be used only daytime, nighttime we cannot use. Okay. Second is based on the shadow found by the sun. So it is approximate, it is not exact. Then we have a hourglass. Inside we have a sand, fine sand. So by tilting up and down, we can measure time. That also approximate. Or burning candle, we can measure time. That also approximate. Or a jar filled with water and already markings are made. At the bottom of the jar, they make a hole. The water drips out. And by seeing how much water gone, we can evaluate how much time passed. But this is also an approximate method. Where using simple pendulum, we can measure time more accurately. That's why the pendulum clock revolutionized the measurement of time. But nowadays we have electronic digital watches, electronic devices by which we measure time more accurately. Okay, so this is some example for a simple, it's a periodic motion. Okay, but in this, if we take the simplest path, suppose the path of the motion is the simplest path what it is straight path, then the motion called as a simple harmonic motion, or it is also known as simple periodic motion. Okay, but quite often we use the term simple harmonic motion. In short, we can also call as a SHM. Okay, so that is a short form we can use while writing the simple harmonic motion. So what is simple harmonic motion? Is a repeated motion because a type of oscillation. So repeated motion about a fixed point, quite obvious. Then it should be on a straight path, simplest path. It should be on a straight path, and of course you should take a definite time to complete the motion. Okay, so that's why what's the basic difference between the periodic motion and the simple harmonic motion? In periodic motion, shape of the path can be anything, circle, ellipse, straight line. So any shape can be. But on this, the body has to move repeatedly again and again. Okay, taking a definite time to complete the motion. So that is a periodic motion. Whereas simple harmonic motion, path must be straight path. So that's why out of these three, with the simple harmonic motion, the body is suspended at the end of the spring. That makes simple harmonic motion. Okay, it's moving in a straight path. What about simple pendulum? Simple pendulum also will make a simple harmonic motion when the pendulum is very long and angle covered is very small. Okay, suppose the angle covered by the string is very small, the path can be taken almost straight. Okay, so that's why it depends on how we make a simple pendulum to vibrate. Either it can make a simple harmonic motion, that means if the angle is very small, so the motion can be taken straight line, it's a simple harmonic motion. If the angle is large, then it makes a periodic motion. Got it? So that's the same simple pendulum arrangement. Either you can make a simple harmonic motion or a periodic motion. But see, by looking at the motion path of the particle, we can tell whether simple harmonic or periodic. But sometimes the path is too big or too small. You won't be able to identify which is the periodic, which is the simple harmonic. Okay. Or suppose the motion takes very fast, then also we are able to identify. So that's why in that case, how to check whether particular motion is a simple harmonic or not? Best thing is you have to get the mathematical relation between the physical quantities. Actually, what relation we need? See, when the body makes simple harmonic motion, the force acting on the body must be restoring force. Why? It is a restoring force. Because suppose the body moves, the force also applied the same direction of motion. What will happen? The body will go. It won't come back. So that's why in order to repeat the motion, the force should be bring back the body to original position. Okay, so that's why the force must be restoring force. So how to elaborate this? This will elaborate. The force acting on it is directly proportional to the displacement. Okay? How much the body moved from the fixed point. More it goes away from the fixed point, more force it apply to pull it back. So that's why the force and displacement both should be directly proportional. But both how they are acting? They are acting in the opposite direction. That's why the necessary condition for the simple harmonic motion or necessary mathematical condition for a simple harmonic motion is this: force directly proportional to displacement, but both means what? Force and displacement, both are in the opposite direction. If this condition, if you get for a given motion, then immediately we can tell the motion is simple harmonic motion. Okay, and that way mathematically we can check whether the motion is simple harmonic or not by checking the relation between force and the displacement. And in this lesson, mainly we are going to study the simple harmonic motion. Now, almost 60-70% of lesson we will be studying about simple harmonic motion. We see some examples also. Okay, and of course we are going to study ideal case. Ideal case means no resistive force, no opposing force. But in reality, you will have some opposing force acting on the body. When there is opposing force acting on the body, a resistive force acts on the body, you know, energy of the body will decrease. So such oscillation we call as a damped oscillation. Yeah? If a resistive force acts on the body, after some time body will come to rest. It won't oscillate for long duration. So such oscillation we call as a damped oscillation, that we are going to study as the next topic. Then last what we have, suppose you want to prolong the oscillation for long duration. What you have to do? You have to force the body to oscillate. And that oscillation we call as a forced oscillation. Okay, and why we have to study simple harmonic motion? What the purpose of this? So as I told you, the many places we study many type of oscillations. Okay, and some oscillations are really very complicated. Any complicated oscillation you take, it can be shown as a different combination of simple harmonic motions. That's if once you understand simple harmonic motion, any type of motion, any complicated motion, we can easily explain using different combination of simple harmonic motion. So that's the reason we are studying this topic, simple harmonic motion. Now last, these two terms, oscillation and vibration. We use quite often both the terms, but actually what's the difference? Mathematically, when you study, there is no difference between oscillations and vibration. We use the same mathematical results, methods to study oscillation vibration. But when you use daily life, so the way of using the terms are different. Actually, what is oscillation? Is repeated motion with low frequency. Okay, means what? So, is a gentle motion. A gentle repeated motion we call as a oscillation. Suppose the repeated motion with high frequency takes place, that means a violent motion takes place. So that is called as a vibration. So that's why the normal talk. No? So oscillation should be used when the repeated motion takes place gently with a low frequency. And the vibration term we have to use when the repeated motion takes place quite often or violently takes place. I'll give example. Suppose the bird flies and sits at the edge of the branch of the tree. At least in videos you might have seen. the branch, that bird vibrates, that bird oscillates. It moves gently up and down like this. It makes less oscillation, less number of oscillation for a given time. That is oscillation. That motion we call as oscillation. But instead of the bird, suppose a monkey jumps on the branch and moves the branch very violently. That means it makes more vibration in a given time interval. So that means what? It vibrates with more frequency. That is called vibration. That means the repeated motion which takes place quite often, we call as vibration. So we don't say monkey oscillates, monkey vibrates. Okay, so that the meaning, the word itself gives a meaning. One is gentle, other is violent. Like. So that's the difference between the use of these two terms, oscillation, vibration. Mathematically, both are one and the same quantities. Okay, and the last one question I want to ask you. You might have seen the race car moving on the track. Okay, suppose in a car, where the car race is taken place, car race or bike race, they have to go 30 or 40 laps, they have to go on the track. Okay, track is not a straight line. Okay, so surely it is not a simple harmonic. Right? Each track got a different shape. But on the path, repeatedly, the car or bike moves again and again. So it is a repeated motion, okay, on a fixed path. But is it a periodic motion? Surely it's not simple harmonic. Path is not straight line, it is not a simple harmonic. But it looks like a periodic motion. Actually, it's not a periodic motion. Why? Depends on the speed of the vehicle. The time taken to complete each lap will be different. Suppose a car or bike goes faster, it will take less time. It goes slower, it will take more time. So each lap time taken will be different. It's not the same. So that's why it is not a periodic also. So then what it is? Oscillation. Okay, when you talk of oscillation, it's a repeated motion on a path. But we never bother how long it takes. Like this. That's an oscillation, vibration, more general term. Okay, in this we come to periodic motion. In this basic one, what it is? Simple harmonic motion. So that is what we are going to study most of the part of this lesson.